You should know that Io is anything but a peaceful moon. In fact, it stands as the most volcanically dynamic world within our solar system. This exploration will guide you through a terrain marked by lakes of molten sulfur and volcanic plumes that rocket hundreds of kilometers into space. You will learn how Jupiter's immense power molds this small moon into a hellish landscape of constant geological upheaval. To grasp the scale of this activity, picture a world where lava flows are incessant, and the ground beneath you shifts moment by moment from the fury of its eruptions. This seemingly fantastical scene is the everyday reality on Io, a place that feels more at home in science fiction than anywhere else in our cosmic neighborhood. So, what makes the study of this moon so critical? The answer is found in its power to push the limits of our knowledge regarding geological and atmospheric processes that might occur on other celestial bodies. Io's astronomical importance extends beyond its stark beauty. It lies in the lessons it can teach us about how other planets and moons across the universe form and evolve. Analyzing its surface and volcanic activity provides vital clues about the potential behavior of worlds we have yet to see. It's as if you have a portal that looks into both the history and the future of the solar system, made possible by observing a small moon that appears to be straight out of a film. As our scientific investigations of Io have progressed, we've made incredible discoveries that have fundamentally altered our perception of how moons operate in space. With every new mission, another chapter is written in this epic narrative, and Io consistently plays the starring role. But what is it that truly drives this moon to be such an energetic place? The cause is buried deep within its core, where colossal forces converge to sustain a world in perpetual transformation. Our understanding of Io is a story of ongoing discovery. As each time we direct our instruments toward this world, we uncover something new that challenges our prior assumptions. For instance, were you aware that the Galileo spacecraft, during its observations in the 1990s, confirmed that Io possesses more active volcanoes than any other object in the solar system? This fact not only cements Io's status as a captivating destination, but also grants us a unique vantage point on the kind of geological forces that could be at play on distant worlds. An exploration of Io inevitably leads us to consider our own planet. What parallels and distinctions can be drawn between Earth and this hyperactive moon? This comparison deepens our comprehension of the mechanisms that sculpt celestial bodies and reveals how external influences, like the titanic pull of Jupiter's gravity, can shape their destiny. This titanic force from Jupiter acts as a dominant player on the cosmic stage, constantly squeezing and stretching the moon. And the intrigue doesn't stop with volcanoes. Io is also enveloped in an exceedingly thin atmosphere, which consists primarily of sulfur dioxide. Can you imagine a world with an atmosphere so fragile that it struggles to remain bound to the surface? This singular characteristic of Io prompts fascinating questions about what forms of life might be able to survive in such extreme environments. Is it possible for any organism, uniquely adapted to these unforgiving conditions, to exist there? Jupiter's magnetosphere, an incredibly potent magnetic field, also has a pivotal influence on Io's existence. The interaction between this magnetic field and the moon generates a highly dynamic environment that impacts both its surface and its tenuous atmosphere. But you might wonder how these phenomena connect to the potential for life on other planets. The truth is, Io's role in the search for extraterrestrial life is profoundly significant, even if it seems inhospitable at first glance. While we have not yet found any direct proof of life on Io, examining its volcanic and geological processes could offer insights into how life might emerge in the most extreme settings imaginable. As our scientific capabilities advance, each new piece of information brings us a step closer to resolving the ultimate question. Are we by ourselves in the cosmos? With a growing number of space missions targeting Jupiter and its moons, Io's remarkable story is still unfolding before our eyes. The unyielding curiosity of humankind compels us to learn more about this enthralling world, and every discovery only sparks new lines of inquiry. What further revelations will future studies of Io provide? The field of space exploration is rich with potential, and this small fiery moon sits at the very center of many of its most exciting possibilities. The adventure of studying Io is just a single thread in the grander tapestry of understanding our position in the universe. Through these investigations, you are not only helping to solve the puzzles of Io, but also strengthening your connection to the cosmos that surrounds us all. So, as we persist in observing and learning, it's important to recognize that every new fact about Io contributes another piece to the vast puzzle of life in space. In the end, Io represents far more than just one of Jupiter's many satellites. It is an emblem of the human condition itself, our tireless quest for knowledge, and our drive to venture into the unknown. Io, Jupiter's captivating moon, truly is a world that seems to have been conceived for a science fiction movie. Yet it is a tangible place circling one of our solar system's gas giants. To better appreciate what Io is, let's begin with its physical scale. Did you know it ranks as the fourth largest of Jupiter's moons? With a diameter similar to that of our own moon, Io is large enough to host a variety of features that make it entirely distinct. Now, try to envision a location where the very surface is constantly being remade. A place where nature is caught in a perpetual loop of destruction and renewal. Io's composition adds another layer of intrigue. It's constructed mainly from rock and metal, which distinguishes it from the numerous ice-covered moons found throughout the outer solar system. This dense makeup is a key factor in its intensely active geology. Let's also consider its distance from Jupiter. Io's orbit is a mere 360,000 kilometers from the planet, a distance less than a quarter of that between Earth and our moon. This close proximity is the primary driver of its geological turmoil, as Jupiter subjects Io to an immense and unrelenting gravitational pull. This force from Jupiter influences not just Io's orbital path, but its very internal structure, generating enormous friction deep inside the moon as it is pulled and flexed, producing the heat that fuels its endless volcanism. This intense activity makes Io the most volcanically dynamic world in our solar system. But you might wonder how that translates to its surface. The result is astonishing. Io's landscape is a masterpiece sculpted by fire. Rather than being pockmarked with impact craters like our own moon, its surface is defined by calderas from volcanic blasts, a world that constantly erases the scars of cosmic collisions with fresh flows of lava. The coloration of Io's surface is just as captivating, with a palette ranging from brilliant yellows to deep reds and browns, all derived from sulfur and its various compounds. When you look at images of Io, it's like viewing an abstract painting where every shade chronicles a unique story of geologic turmoil, with each specific color signifying a different kind of volcanic process. As our investigation of Io continues, we find it possesses an atmosphere, albeit an incredibly thin one, composed primarily of sulfur dioxide. This presents a puzzle. How does such a small celestial body manage to hold on to any atmosphere at all? The solution is found in its ceaseless volcanism, which constantly replenishes gases that would otherwise escape into space, creating a fragile envelope of air utterly unlike our own. Io's distinct character becomes even clearer when you compare it to the other Galilean satellites, Europa and Ganymede, which are renowned for their ice-covered crusts hiding vast subsurface water oceans. Io, by contrast, is a world on fire, a beacon of geological vitality that transforms our understanding of what a moon can be. and challenges us to rethink our criteria for exploration and potential habitability. The relentless geology of Io is more than just a visual marvel. It offers profound scientific insights into gravitational interactions between celestial bodies. Jupiter's influence is the key, as its massive gravitational pull constantly squeezes and stretches the moon, generating immense internal heat through friction. This perpetual process of compression and deformation is what keeps Io's core molten and active, setting it apart from countless other geologically quiet moons in the solar system. Our journey to understand Io is far from complete, as the data from missions like Galileo and the ongoing Juno probe only deepens our appreciation for its complexity. With each technological leap forward, we inch closer to unraveling the mysteries of this volcanic moon. You can't help but wonder what astounding new discoveries await us as we continue to explore Io in the decades ahead. Io stands as a remarkable natural laboratory, showcasing geology in ways that defy imagination and providing a unique window into the mechanics of our solar system. Have you ever considered how a tiny moon circling a gas giant like Jupiter could possess such a stunning and varied terrain? The explanation is rooted in the powerful geological forces that are ceaselessly transforming its surface, presenting a landscape that pushes the boundaries of our planetary knowledge. As you examine Io's geology more closely, you find a perplexing situation regarding its craters. Like any body in space, it is subject to a constant barrage of asteroids and comets, yet its surface lacks the extensive scarring you would expect. This is because the moon's hyperactive volcanism acts as a planetary resurfacing machine, continuously burying impact sites under fresh layers of lava and sulfur, making its terrain perpetually new. The landscape of Io is truly alien, something you might envision from a science fiction epic, with its stark contrast of vast, smooth plains and jagged mountains. Some of these peaks soar to elevations of up to 5 kilometers, raised by unimaginable geological forces. When its volcanoes erupt, rivers of molten rock and chemical compounds carve through the terrain, cooling to form a surreal panorama that might look like a desert, but is instead coated in a bizarre blanket of sulfur. The moon's dramatic activity isn't just a surface-level phenomenon. Scientists theorize that a vast ocean of magma churns beneath Io's crust, feeding its hundreds of volcanoes. This concept naturally sparks our curiosity about what other secrets might lie in its depths. With every new piece of information, more questions arise, leading us to contemplate the ultimate possibility. Could some form of life have found a way to exist in this incandescent world? Io's surface showcases features that go far beyond simple craters and volcanoes, including unique formations known as perpetually, immense depressions believed to be the result of colossal eruptions. These structures paint a picture of chaotic volcanic artistry, prompting you to wonder about their origins and the geological history they reveal. The moon's landscape is defined by lava and sulfur, which take the place of water, a key agent of erosion on other worlds. This starkly arid volcanic environment begs the question of what it means for the potential for life. For while the surface is clearly inhospitable, conditions deeper below may prove more favorable. The relationship between Io's volcanic fury and its delicate atmosphere is also a subject of great interest. The volcanoes do more than just reshape the terrain. They also expel gases that enrich its thin atmospheric layer. You have to ask whether these emissions could be signs of even more intricate processes occurring within the moon. Science is a field of constant advancement, and with every new piece of data, we move closer to understanding the truth. As we delve deeper into the nature of Io's surface, a natural comparison to other bodies in the solar system arises. Are there other locations where the geological engine runs with such intensity? The answer is yes, but the sheer extremity of Io's activity is unparalleled, transforming it into an ideal natural laboratory for the study of planetary science. In essence, Io's surface is a geological spectacle, a realm where nature unleashes its power in forms you won't see anywhere else. The breathtaking combination of volcanism, impact craters, and bizarre landforms offers you a window into a world in a constant state of flux. Every single eruption, crater, and lava flow contributes to a larger narrative that we are only just beginning to decipher. As scientific inquiry presses on, each new mission holds the promise of uncovering yet more wonders from this captivating moon, leaving you to wonder what other secrets Io has yet to reveal. A volcano is, at its core, simply an opening in a planet's crust that provides a pathway for magma, the hot, molten rock from its interior, to escape onto the surface. You can visualize this by thinking of a kettle on a stove. As the water heats, steam and bubbles build up, pushing to get out. On Io, this same principle is magnified to an incredible degree, as intense internal heat drives magma to burst forth in spectacular volcanic displays. The scale of volcanic activity on Io is truly staggering. Unlike on Earth, where volcanic eruptions can be sporadic, Io offers a perpetual show of geologic power. Some of its eruptions are so violent that they launch material hundreds of kilometers into space, reaching heights more than 3 times that of Mount Everest. It's as if the moon itself is a living being, constantly exhaling plumes of gas and lava. So, what is the engine behind this relentless activity? The answer is found in the interplay between Jupiter's immense gravity and Io's own rotation. The sheer mass of Jupiter exerts a powerful gravitational pull, continuously stretching and squeezing Io. This constant flexing generates enormous internal friction, which in turn produces heat, similar to how an eraser gets warm if you bend it back and forth in your hands. On Io, this process generates enough energy to keep its interior magma molten, thereby fueling its ceaseless volcanism. The eruptions on Io are not merely a visual phenomenon. They have a profound and ongoing effect on its surface. If you imagine each eruption as a brushstroke on a vast canvas, you can see how the landscape is perpetually being transformed. Fresh lava flows bury older terrain, creating a vibrant mosaic of colors and textures. Furthermore, these eruptions build mountains and carve out craters, reshaping Io's geography in truly remarkable ways. When you examine the types of volcanoes on Io, you find they differ from those on Earth. Many are classified as perpetually, which are large, complex volcanic depressions formed by explosive eruptions and subsequent surface collapse. These features can be vast, with some spanning tens of kilometers in diameter. Picture a gigantic crater, not as an empty basin, but as a caldera filled with glowing, churning lava. The distinctive bright yellow coloration of Io's lava is due to a mixture of sulfur and other chemical compounds. As this material cools on the surface, it can create a wide array of landscapes, from expansive flat plains to towering steep mountains. This cycle of cooling and crystallization is a source of fascination for scientists, as every eruption can leave behind a new kind of terrain, making Io a world of endless surprise. Beyond the explosive eruptions, Io's geological life includes phenomena like vast lava flows. These behave much like rivers on Earth, with molten rock slowly advancing across the surface, carving out channels and pathways. You can imagine a shimmering river of lava, flowing steadily and illuminating the darkness with its incandescent glow. This constant motion is integral to the moon's life cycle, where cooled lava hardens into new land, only to be fractured and covered by the next eruption. Our knowledge of these eruptions and lava flows has been captured through images from space missions, most notably Galileo. These observations have allowed scientists to document the dramatic changes on Io's surface over time, and to analyze the frequency of its volcanic events. This data has provided us with a much clearer understanding of how internal heat and volcanic processes shape a planetary body. There's no question that Io's dynamic volcanism raises some profound questions. What can this activity teach us about the formation of other worlds in our solar system? Io's geology might hold clues to the evolution of moons and planets in other star systems as well. Moreover, studying these powerful processes can also help us better comprehend the geological history of our own planet and its neighbors. In the end, Io's active volcanism is a breathtaking spectacle that not only defines the moon's character, but also expands our entire framework of geology. From its explosive plumes to its sinuous lava flows, every facet of this activity tells a story of immense heat, constant motion, and perpetual transformation. As Io continues its gravitational dance with Jupiter, its volcanoes beckon you to keep exploring the secrets hidden just beneath its colorful, chaotic surface. Whenever you next gaze up at Jupiter in the night sky, consider that one of its moons is a world of perpetual activity, where every eruption offers a glimpse into the universe's fundamental mysteries. The tectonic processes on Io are a truly compelling phenomenon, beckoning us to investigate the unseen forces that sculpt its surface. Its uniqueness stems from a powerful combination of intense gravitational pressures and profound internal heat, setting it apart from other bodies in the solar system. Picture Io as a flexible sphere that is endlessly being squeezed and released. This moon not only boasts active volcanoes, but also features a surface that continually flexes and transforms, not unlike the tectonic plates of our own planet. The immense gravitational pull of Jupiter acts on Io with relentless force, subjecting it to constant stress with each orbit, an effect comparable to a powerful massage. This cycle of tension and relaxation not only warps its surface, but also generates the internal friction and heat that fuel its remarkable geological dynamism. What is the consequence of heating rock to such extremes? It becomes more pliable and, under certain conditions, can even liquefy into magma, raising questions about the kinds of landforms that can exist on a moon in constant flux. The craters on Io are unlike those you might find on our moon or Mars. Instead of static impact scars, many display clear evidence of renewal and alteration. You can visualize Io's landscape as a spiderweb that is ceaselessly being respun, as volcanic eruptions not only forge new craters, but also bury older ones beneath fresh lava flows, creating a captivating cycle of destruction and rebirth. Observing this world, you might naturally wonder if a direct link exists between its volcanoes and its tectonic activity, and the answer is an emphatic yes. Each volcanic eruption is the climactic release of immense stress built up within Io's crust. Once the pressure becomes overwhelming, lava violently breaches the surface, fashioning entirely new landscapes. Breathtaking images of these events, such as those captured at the Loki volcano, provide compelling evidence of how tectonic forces directly drive volcanic behavior. The movement of tectonic plates on Io is far less predictable than it is on Earth. Rather than gliding past one another, its crustal plates frequently crack and fracture, resulting in a tormented surface, riddled with towering mountains and deep valleys. This chaotic environment poses a significant challenge. How can we possibly study such a volatile and ever-altering world? To piece together its geological history, scientists rely on high-resolution imaging and archive data from various space missions, with each new observation offering fresh clues. This tectonic activity, however, is not confined to the surface alone. The interplay between internal heat and external gravitational pressure can trigger a process known as subduction, where one section of the crust is forced to sink beneath another, much like what occurs on Earth's ocean floors. Investigating this phenomenon helps scientists develop a clearer understanding of how both volcanoes and craters are formed and reformed across Io's landscape. A particularly fascinating dimension of Io's tectonics is how it contrasts with the subsurface ocean thought to exist on its sibling moon, Europa. The crucial difference is that while Europa harbors a vast ocean of liquid water, Io's interior is significantly hotter and drier. This leads to an important question. How does the total absence of water influence Io's tectonics? The explanation likely resides in the composition of its crust, which consists almost entirely of rock and minerals. Without water to act as a lubricant, these dry materials are far more brittle and prone to cracking and shifting under stress, potentially making Io's tectonic activity even more intense. Io's surface is scarred with features that vividly proclaim its turbulent geological past. It is a world of mountains that dwarf any on Earth, and vast depressions that appear as deep gashes on its face. Each of these dramatic formations serves as a geological archive, offering insights into how the moon has been radically transformed over millions of years of turmoil. These processes provide invaluable lessons that extend far beyond Io itself. By examining how this moon responds to Jupiter's powerful influence, scientists can extrapolate that knowledge to understand geological processes on other worlds. For instance, it's plausible that moons orbiting planets in other solar systems might be experiencing similar forms of tidal tectonics. Answering these questions not only deepens our comprehension of our own solar system, but also better equips us for future voyages of discovery into the farthest reaches of the cosmos. As our exploration of Io continues, it is apparent that its tectonic activity is just one element of a much larger, more complex puzzle. This volcanically charged and geologically restless moon serves as a perfect natural laboratory, enabling us to study the cosmic forces that shape planets and their satellites. Its story is a narrative of constant transformation, with every eruption, fissure, and crater adding a new line to its chronicle. As long as scientists continue their analysis, we can be certain that Io holds many more surprises. Although incredibly thin, Io's atmosphere is another fascinating component that enriches our understanding of this volcanic world. You may ask what makes such a tenuous envelope of gas so important for scientific study. Primarily, it is composed of sulfur dioxide, the same gas you would encounter near a volcanic eruption here on Earth. The significance of this gas lies in what it represents. It is the undeniable signature of the relentless volcanic outgassing that defines the very nature of Io. When you think of Io's atmosphere, it's best to envision it as a delicate, almost transparent veil that offers little in the way of cover. Extending only a few hundred kilometers above the surface, it is minuscule compared to Earth's atmosphere and provides virtually no protection from cosmic radiation. The key to its existence is constant replenishment from the moon's surface. When Io's volcanoes, like the famous Tvashtar, erupt, they violently expel massive quantities of sulfur dioxide and other gases, continually feeding this fragile atmospheric layer. In the case of Io, while the erupted gases scatter swiftly, a portion lingers to create an atmosphere, enveloping the moon in a sort of cloud. Scientific observations reveal that this atmosphere is in a constant state of flux. There are moments when it grows denser, and other times when it seems to vanish almost completely. The reason for these fluctuations lies in the interplay between volcanic outpourings and the gravitational pull of Jupiter, whose immense gravity acts like a magnet, drawing some gases toward itself while letting others drift into space. Could there be more to find within Io's atmosphere? Certain observations hint that under specific conditions, you might detect traces of other compounds, such as water vapor and carbon dioxide. This suggests Io is more than just a volcanic world. It possesses a chemical complexity that could offer deeper insights into its history and makeup. The dialogue between Io's atmosphere and Jupiter's magnetosphere, a vast magnetic field that surrounds the planet and affects everything within its reach, presents another fascinating area of study. Scientists theorize that gases in Io's atmosphere can become ionized when they interact with this magnetic field, generating electrical currents and auroral displays akin to those on Earth. Just try to picture an aurora unfolding over Io. It would be an absolutely breathtaking spectacle. Furthermore, Io's thin atmosphere holds significance for the quest for life elsewhere in our solar system. Although it is profoundly hostile to life as we understand it, analyzing its atmosphere helps us grasp the essential conditions for life's formation and survival. Should we ever discover extraterrestrial life, it will be vital to understand how atmospheres are created and maintained in such extreme settings. Studying Io's atmosphere also provides clues to the Moon's past. Every gas detected in its atmosphere narrates a story of its origins, its evolution, and the forces that have sculpted its surface. This is a critical piece of the puzzle for understanding not just Io, but other celestial bodies as well. As our technology progresses, we can anticipate that future space missions will uncover much more about Io's atmosphere. New probes are poised to gather more precise data, potentially analyzing its gases in real time. What marvels might be waiting just over the horizon? It's possible we will find something entirely unexpected that revolutionizes our perception of this moon and its role in the cosmos. Io's atmosphere, despite being fragile and fleeting, is an indispensable component in understanding this moon. It serves as a window into the geological and volcanic forces that define it, helping us connect the dots between chemical composition, history, and the possibility of life on other worlds. So, as you observe Io, remember that even its tenuous atmosphere is brimming with surprises and valuable lessons. Ultimately, each new insight into its atmosphere brings us a little closer to comprehending not only this unique moon, but also the immense universe that envelops us. The exploration of Io serves as a powerful reminder that, regardless of the challenges, space always holds something new to discover. Our search for answers persists, and every piece of information we collect moves us nearer to solving the solar system's great mysteries. Jupiter's incredible gravity has a remarkable influence on the most volcanically active moon in our solar system. But what does this truly entail? To grasp this, you must first appreciate Jupiter's enormous scale. This gas giant is so immense that its gravitational field can capture asteroids and comets, and it wields an extraordinary power over its moons. For Io, this force is the very driver of its geological and volcanic turmoil. Jupiter's gravity functions like a colossal engine, powering the volcanism on Io. Picture a relentless stretching motion, as if you were constantly pulling on a rubber band. This gravitational tug-of-war produces heat deep inside Io, maintaining its molten interior and fueling its spectacular volcanic eruptions. The outcome is a moon that stands as a geological marvel, perpetually being remolded by the forces of its gigantic neighbor. Each time Io traces its elliptical path, the gravitational pull from Jupiter distorts it, generating immense internal stress. This process heats Io's core, which in turn leads to volcanic eruptions that blanket its entire surface. Did you know that Io is subject to gravitational tides? This is a phenomenon much like the tides in our oceans, but instead of water, you are dealing with molten rock and magma. Jupiter, along with other moons like Europa and Ganymede, produces a cycle of tension and relaxation that keeps Io in a continuous state of geological unrest. This tidal effect is what not only initiates volcanism, but also preserves the moon's active and dynamic surface. The internal heat created by this tidal friction is the engine for Io's renowned volcanoes. These are truly unique as they erupt not just lava, but also sulfur and sulfur dioxide, painting landscapes with vivid and ever-shifting colors. Imagine a celestial light show where, instead of pyrotechnics, you have volcanic plumes shaping a completely different world. A compelling aspect of this gravitational dance is its effect on the composition of Io's surface. Jupiter's powerful gravity does more than just regenerate the volcanic terrain. It also modifies the chemistry of the materials on the moon. As magma surges to the surface and cools, minerals and chemical compounds are resorted, fashioning a mosaic-like pattern of extraordinary colors and textures. Io's volcanic eruptions are fundamentally a manifestation of the interplay between its own gravity and that of Jupiter. Some of the most massive eruptions can launch material to heights equivalent to 3 times the height of Mount Everest. This is not only awe-inspiring, but also means Io's surface is in a state of constant renewal. Every eruption is like a fresh chapter in this moon's story, a testament to its vibrant and active nature. It's captivating to think about how this gravitational dynamic could influence the chances of water existing on Io. Although the moon is incredibly arid compared to others like Europa, the warmth generated by Jupiter's gravity might still affect any subsurface water. This opens up compelling questions about the potential for life and how a planet's gravitational pull can shape the habitability of its satellites. Furthermore, Jupiter's gravity also impacts Io's exceptionally thin atmosphere. This immense force not only anchors particles to the surface, but is also crucial for retaining some of the gases expelled during volcanic eruptions. Understanding this process is essential for comprehending how Io's environment functions and interacts with Jupiter's vast magnetic field. Jupiter's gravitational sway has much broader consequences for the entire solar system. By examining Io and its relationship with Jupiter, you gain profound insights into the formation processes of moons and planets. Gravity stands as a principal force not just in Io's geology, but also in the development and evolution of all other celestial objects. Space missions have returned an enormous amount of information detailing how Jupiter's gravity affects Io. The images and data gathered have enabled scientists to construct better models of the dynamic between the moon and its host planet. Every new piece of data serves as another clue to solving the puzzle of how these cosmic giants interact across space. In this respect, Io acts as a perfect natural laboratory, giving us a chance to observe the forces and processes that are active in other parts of the cosmos. Jupiter's gravity is more than just a force that sculpts Io's surface. It stands as a powerful testament to the effects gravity can exert throughout the universe. This mesmerizing bond between Jupiter and Io highlights just how important it is to keep exploring these alien worlds. Every breakthrough could unlock new levels of understanding, not only about our own solar system, but also about distant planetary systems where gravitational forces might be similar or even more intricate. Ultimately, Jupiter's gravity is the central element dictating Io's volcanic and geological state. This cosmic interplay doesn't just animate the moon, it offers you invaluable lessons about the workings of the universe. And with each new piece of information, our questions multiply, driving our curiosity to venture beyond our home planet. So what is it that keeps Io, the solar system's most active moon, ablaze with fire? The solution to this fascinating puzzle is found in Io's internal heat, a remarkable phenomenon that has mesmerized scientists for decades. This inner warmth is the engine that powers its extraordinary volcanism, making it an utterly unique destination in our cosmic vicinity. To start, you need to appreciate that Io is no ordinary moon. Picture a pressure cooker that is perpetually being heated. For Io, this heat originates from multiple sources, but the most dominant is the immense gravity of Jupiter. The gas giant's colossal gravitational field constantly stretches and squeezes the moon in a process referred to as tidal heating. But what exactly does that entail? As Io travels in its orbit around Jupiter, it becomes caught in a gravitational tug-of-war with its neighboring moons, such as Europa and Ganymede. This constant struggle of forces causes Io's shape to deform slightly with every revolution, as if it's being molded by unseen hands. With each flex, Io's interior heats up, establishing the ideal circumstances for its breathtaking volcanic displays. You can almost hear the hiss of a pressure cooker about to vent steam. That is a perfect metaphor for the internal condition of Io. This internal warmth, however, isn't produced by Jupiter's gravity alone. The decay of radioactive elements deep within Io's core is another significant contributor. As these elements break down, they liberate energy as heat, much like a battery warms up during use, creating a simmering cauldron that sustains the moon's volcanic fury. But what impact does all this have on Io's surface? The immediate result is that its geology exists in a perpetual state of transformation. Io's volcanoes are dramatically different from those on Earth. Instead of the thick, viscous lava you might find in a place like Hawaii, they eject enormous plumes of sulfur and sulfur dioxide that create surreal, alien landscapes. Picture a fireworks show where, instead of vibrant colors, you witness vast yellow clouds of sulfur. As these volcanoes erupt, Io's terrain is ceaselessly remade, with craters forming and then vanishing, new mountains rising, and old geological features being erased. This constant reshaping provides a window into both Io's past and present, revealing how internal heat sculpts its surface in ways you could hardly fathom. Each eruption is a reminder that Io is alive in a manner that few other bodies in the solar system can claim. The interplay between this inner heat and the surface also has consequences for Io's atmosphere. Although its atmosphere is incredibly tenuous, it is composed of gases liberated by the volcanoes. This reveals that the moon's internal heat doesn't just modify its geology, but also influences the environment surrounding it. This cycle of volcanic outgassing and atmospheric replenishment fosters a dynamic and ever-shifting world. Now, you might ask just how hot it gets inside Io. While we don't possess a thermometer to take its internal temperature, scientists estimate it could be as high as 1,000 degrees Celsius. That's more than enough to melt rock and drive the flow of magma just beneath the surface. Imagine the molten centers of Earth's greatest volcanoes, but instead of being relatively stable, they are in a state of constant turmoil. Io's intense internal activity also creates fascinating consequences for its magnetosphere. Being in a continuous state of flux, the moon generates a magnetic field of its own, which then interacts with Jupiter's immensely powerful one. This exchange results in a complex system of forces that shapes its atmosphere and environment. Much like a cosmic dance between two giants, this phenomenon demonstrates how internal heat is significant not just for Io itself, but for the solar system at large. When you consider our search for life elsewhere in the solar system, Io's internal heat prompts some fascinating questions. Despite being a hostile world, could some form of life, perhaps microbial, manage to thrive in such extreme conditions? The heat and volcanic activity foster a chemically rich environment, which is a fundamental requirement for life as we understand it, forcing us to rethink where life might emerge. As we investigate the source of Io's internal warmth, you must remember how much remains undiscovered. Scientists are counting on future missions to gather more data on its internal structure and volcanic processes. Every new expedition promises to unlock more secrets about Io's formation and its evolution into the captivating world we see today. And perhaps one day, humanity will deploy probes to its scorching surface for an unparalleled look at this fiery moon. Io's intense internal heat is more than just a remarkable phenomenon. It serves as a powerful reminder of the universe's complexity, illustrating that every planet, moon, and star has its own distinct narrative. When you observe Jupiter's volcanic moon, Io, it's impossible not to compare it to its Galilean siblings, Europa, Ganymede, and Callisto. Each one possesses a unique story, but Io is undeniably the most dynamic and active of the group. To understand what makes this particular satellite so special, it's crucial to examine its similarities and differences with its neighbors. In terms of size, Io is slightly smaller than our own moon, though this does nothing to diminish its intrigue. Compared to Europa, with its icy surface concealing a vast subterranean ocean, Io is a world of complete contrast, defined by its volcanoes and fiery vistas. Imagine standing on its surface, surrounded by eruptions and landscapes that feel torn from science fiction. Ganymede, the largest moon in the solar system, also harbors a subsurface ocean, but its surface shows significantly less activity than Io's. This is where Jupiter's immense gravity becomes a critical factor, as its pull creates a cosmic dance that generates stress within the interiors of all these moons, fueling Io's incredible energy. Callisto, by contrast, resembles a giant pockmarked relic, its surface saturated with impact craters that signal a long history of geological quietness, making it far less compelling from a volcanological standpoint. So, what do these differences imply for the search for life? The more active moons, like Io and Europa, may hold the answer. While Europa's hidden ocean gets the most attention, Io's own geothermal activity could sustain niches where life, profoundly different from anything we know, might exist. As we explore these moons, the fundamental question arises: could any of them actually support life? It's crucial that we don't underestimate Io's potential in this regard. The composition of these worlds also tells a story, as Io is primarily composed of silicates, distinguishing it starkly from Europa's icy shell. This variation affects not only their appearance, but also their geological behavior, with Io's rich sulfur deposits painting its landscapes in stunningly vibrant colors. Furthermore, studying Io offers clues about geological processes on other worlds. Understanding how Jupiter's gravity interacts with Io's interior can help us model how distant exoplanets form and evolve. The Galilean moons also teach us about the sheer diversity within our solar system, with each one acting as a natural laboratory for studying different cosmic processes. In this way, Io and its sisters become essential pieces in the puzzle of our own planet's history and dynamics. Of course, we must also acknowledge the importance of space missions, from the Galileo probe to future exploration concepts, as each step brings us closer to unraveling the mysteries these worlds conceal. The Galileo mission, which launched in 1990, marked a true milestone in our exploration of the solar system, particularly concerning Io. To appreciate its significance, you have to consider the scientific context of that era. Interest in Jupiter and its moons was surging, yet many profound mysteries remained unresolved. Galileo was designed to answer the very questions that captivated us all, seeking to uncover the secrets hidden beneath Io's perpetually active and ever-changing surface. When the Galileo spacecraft entered Jupiter's orbit in 1995, it set the scene for some truly incredible revelations. Picture a probe navigating through the gas giant's rings to approach Io, the most volcanically active moon in our entire solar system. The initial images transmitted back to Earth offered a window into a completely alien landscape, forcing you to envision a terrain scarred by craters and erupting volcanoes, establishing Io not just as a moon, but as a dynamic natural laboratory for geology. The mission's data confirmed that Io is a world where volcanic activity is not merely a possibility, but a constant, violent reality. Plumes of sulfur and other compounds are continuously blasted into space, forming a thin but captivating atmosphere. The sheer density of active volcanoes was an extraordinary boon for planetary scientists, but Galileo's discoveries didn't end there. Its instruments revealed that Io's surface is blanketed in sulfur and its compounds, which is what gives the moon the distinctive yellowish tint that sets it apart from its Galilean neighbors. Galileo's investigation extended beyond the surface to study Jupiter's magnetosphere and its profound relationship with Io. This link is especially compelling because the planet's immense gravitational pull is the primary driver of the moon's geological turmoil. The mission provided a unique chance to observe how Jupiter's magnetic field directly influences the volcanic ejection of gases, solving the puzzle of how such a small celestial body could generate so much internal heat. This was explained by the constant internal friction created by Jupiter's gravity, a finding that fundamentally altered our models of planetary geology. Among the mission's most thrilling achievements was the live observation of a volcanic eruption. Just try to imagine witnessing such a powerful event from hundreds of millions of kilometers away. Galileo successfully captured an image of a volcanic plume spewing material high into space, providing one of the first ever direct recordings of volcanic activity on another world's moon, and leaving the scientific community in a state of absolute awe. Ultimately, the information from Galileo did more than just deepen our knowledge of Io. It fundamentally changed how we perceive moons in general. Before this mission, moons were largely considered to be inert, frozen worlds. But Io proved they could be incredibly dynamic and complex. This shift in perspective prompted scientists to ask new questions and inspired a new generation of missions to explore other celestial bodies in our solar system and beyond. Reflecting on the Galileo mission, you can't help but marvel at the power of human ingenuity and our relentless drive to explore. The probe taught us that Io is a place brimming with surprises, and that every answer we find in the cosmos only opens the door to more profound questions. Galileo's legacy is a testament to our insatiable curiosity and continues to inspire every new study of Io's enduring mysteries. That legacy was carried forward by the Juno mission, which began its journey in 2011. After traveling for nearly 5 years, the spacecraft successfully entered orbit around the gas giant in 2016. Since its arrival, Juno has been transmitting revolutionary data that has completely transformed our comprehension of both Jupiter and its complex family of moons. One of the central objectives of the Juno mission is its detailed investigation of Jupiter's gravitational and magnetic fields. Its advanced instruments have revealed that the planet's gravity is vastly more complex than anyone had anticipated. You can visualize it as an immense, interwoven network of forces that influences not only Jupiter but its moons as well. Within this gravitational web, Io holds a critical position, as its intense volcanism is inextricably linked to the pull of its parent planet. Juno has also provided new insights into how Jupiter's magnetosphere, a gigantic bubble of energetic particles enveloping the planet, interacts with Io. The spacecraft has demonstrated that the moon is in a constant state of exchange with this magnetic bubble, a process that gives rise to stunning phenomena like auroras. However, the auroras shimmering above Io are profoundly different from the familiar northern and southern lights we witness here on Earth. In the immense and enigmatic region around Jupiter, a compelling question emerges about Io, the solar system's most volcanically active moon. To grasp the full scope of what makes Io so unique, you first need to explore the captivating realm of Jupiter's magnetosphere. Picture this magnetic field as a colossal, unseen barrier that envelops the planet, reaching far beyond its atmosphere and shaping the entire local environment, including its moons. The interplay between Io and Jupiter's magnetosphere gives rise to a truly remarkable effect. As the moon travels along its orbital path, the powerful magnetic field subjects it to a cycle of immense stress and release. This constant gravitational tug-of-war not only impacts Io's surface, but also ignites a cascade of geological and volcanic events, with the moon's fiery volcanoes being the most direct and spectacular result of this deep connection. The internal heat radiating from Io's core is intensified by energy channeled from the magnetosphere, trapping the moon in a celestial dance where Jupiter's forces constantly push and pull. This process superheats Io's interior, leading to its frequent and violent volcanic eruptions. This influence doesn't stop at geology. It also shapes Io's incredibly thin atmosphere by interacting with escaped gases to generate brilliant auroras over the moon's poles, much like the northern lights on Earth. Data from the Juno mission has shed new light on the chemical makeup of Io, leading to some astonishing findings. Among the most unexpected was the identification of elements like sulfur and sodium within its tenuous atmosphere. This discovery has profound implications for the moon's geology, suggesting that Io's volcanoes are not just active, but are also spewing out chemical compounds that offer valuable insights into the moon's deep internal structure. You can think of each volcanic plume as an encrypted message from deep within Io, narrating a piece of its planetary story. These eruptions, which are brighter than previously thought, result from intense activity, launching gases and particles far into space. This new understanding compels us to ask what other secrets are hidden within the intricate relationship between Jupiter and its volcanic moon, and what future messages these eruptions might carry. Thanks to Juno's detailed data, scientists have developed far more precise models of Io's volcanic behavior. While we previously relied on theories, this new information is providing a much clearer picture of the processes at play. Simulations now confirm that the moon's internal turmoil is powered by the immense tidal forces from Jupiter's gravity, essentially keeping Io's interior in a state of perpetual motion, much like a seething cauldron. Furthermore, the Juno mission has confirmed that Io's volcanism is even more dynamic than we had imagined. The images and data collected are revolutionizing our understanding of how its surface features are formed and how they change over time. Far from being a static world, we now see that Io's landscape is in a constant state of transformation, suggesting that each new observation might reveal a different face of the moon. Juno's observations have also highlighted that Io is not unique in its intense relationship with Jupiter. The other Galilean moons, including Europa and Ganymede, undergo comparable interactions, though the effects manifest differently. This realization prompts us to consider what the study of Io can teach us about the formation of other celestial bodies, with potential answers that could reshape our understanding of the entire solar system. Another area of intense focus for scientists has been the impact of radiation on Io. The Juno spacecraft successfully measured the extreme radiation levels the moon endures, which not only bombard its surface, but also likely alter the chemistry of its atmosphere. This raises a critical question. How has Io managed to adapt and even thrive in such a punishing and hostile environment, making it an endlessly compelling subject for study? With the Juno mission still underway, scientists are eagerly anticipating the chance to analyze a continuous stream of new data. Every piece of fresh information has the potential to unlock doors to questions we haven't even thought to ask yet. On each pass, Juno acts as a messenger, delivering news from a distant world brimming with activity and surprise, fueling the boundless human curiosity that drives us to explore. As the volume of data grows, researchers are starting to discern patterns and connections that were once invisible, keeping the spirit of space exploration burning bright. This process embodies the very nature of discovery, where every answer inevitably leads to a new set of questions, perpetuating the cycle of knowledge. The significance of the Juno mission, therefore, reaches far beyond Io, offering us a more profound comprehension of the solar system's mechanics as a whole. Ultimately, the Juno mission has dramatically transformed our perspective on Io, providing a much sharper view of its volcanic activity, its chemical composition, and its intricate dance with Jupiter. Every new finding marks another milestone in our grand journey to comprehend the cosmos. As we persist in our exploration, we are bound to find answers we never even dreamed were possible, and that is the true thrill of discovery. The journey into Io's secrets is, without a doubt, far from complete. These auroras, however, are far more powerful and showcase the intricate interplay between this moon and the gas giant. One of the most captivating elements of this dynamic is the function of plasma. Are you aware that Io is under constant assault from charged particles originating in Jupiter's magnetosphere? This plasma doesn't just reshape Io's surface. It is a critical factor in driving both its auroras and its volcanic activity, essentially trapping the moon in a perpetual electrical storm where energy accumulates and then erupts in spectacular fashion. The magnetosphere's reach extends far beyond Io, shaping the cosmic environment that envelops the moon. For instance, the plasma resulting from this interaction forms a vortex of particles that could influence the creation of a material ring around Jupiter. Consequently, investigating Io offers us valuable insights into the mechanics of the entire Jovian system, making it a key to understanding its larger workings. Every space mission has furnished us with increasingly precise data on how Jupiter's magnetosphere impacts Io. Probes have relayed crucial information that deepens our comprehension of this complex relationship. But what does this imply for the future of our research into Io, and, more broadly, for the exploration of space? As our knowledge of Io and its magnetosphere grows, new avenues of scientific inquiry open up. Scientists are especially keen to understand how this interaction might affect the potential for life on other moons and planets. Although Io is an inhospitable world, analyzing its magnetosphere could offer clues about how other celestial bodies might sustain life-supporting conditions. Jupiter's magnetic field also prompts questions about the formation and evolution of entire planetary systems, leading us to wonder if these immense magnetic forces could have contributed to the creation of other cosmic bodies. The answers to these inquiries will not only illuminate the nature of Io, but also cast new light on the history of our solar system. In essence, Jupiter's magnetosphere is an indispensable piece of the puzzle for comprehending Io's dynamics. From its sway over active volcanoes to its part in generating breathtaking auroras, the bond between Jupiter and Io stands as a testament to the universe's complexity. Each new piece of information brings us closer to solving the enigmas of this compelling moon. So, the next time you gaze at the night sky and consider Io, recall the immense magnetic power that is molding its fate, a destiny filled with volcanic fire, ethereal light, and mysteries still waiting to be solved. To explore Io is not merely to journey to a faraway world. It is to venture into the very heart of our solar system's story. But could a distant, volcanic moon like Io possibly harbor water? For many, The answer would seem to be a firm no, given its surface is a hostile landscape of erupting volcanoes. Yet, science is posing some fascinating questions about the presence of water on this Jovian moon that demand exploration. The hunt for water on Io is more than a simple academic curiosity. It could be the essential clue to grasping the moon's internal processes and its ultimate potential for habitability. Io is famously the most volcanically active body in our solar system, but you might wonder how this connects to water. Consider a ball that is ceaselessly squeezed and released. This is analogous to the forces at work on Io. The gravitational pull from Jupiter and its other moons creates immense tidal friction deep inside Io, generating incredible heat. The critical question is, what happens to all this thermal energy? In theory, it could be sufficient to melt subterranean ice, allowing water to emerge as vapor, or even exist in a liquid state far beneath the hostile surface. Water is the fundamental ingredient for life as we know it, which is why the potential existence of it on Io prompts scientists to ask if this extreme setting could host undiscovered life forms. The idea of organisms thriving in lava lakes or volcanic vents on Io might sound like science fiction, but it represents a serious field of study within astrobiology. Now, let's consider Io's atmosphere, which is so thin it's nearly a vacuum, resulting in incredibly harsh conditions. Even within this unwelcoming environment, instruments have detected traces of compounds that could signal interactions with water. Some researchers theorize that sulfur vapor from volcanic plumes might mix with ice deposits, creating the right conditions for water to persist. But what if I were to tell you that water on Io might not conform to our usual expectations? Instead of wide oceans, it could be locked away in small, subsurface reservoirs, akin to a buried, frozen lake. This prospect is thrilling because it implies that, despite its severe environment, Io might contain pockets where the chemical reactions necessary for life could take place. Locating and verifying the existence of water on Io is, however, an immense challenge. Technology is absolutely vital in this quest. As our telescopes and exploratory probes grow more sophisticated, our ability to detect signs of water in the most unlikely locations improves. So, what instruments do scientists have at their disposal? From high-resolution imaging systems to advanced spectroscopy, researchers can now meticulously analyze the composition of Io's surface, searching for the telltale chemical signatures of water. Each new observation only deepens the mystery and expands the horizons for future exploration. But if we do find water, what would it mean for our comprehension of the solar system? Confirming the presence of water on Io would force us to rewrite our textbooks on the habitability of celestial bodies. Instead of focusing our search for life on planets like Mars or moons such as Europa, we might broaden our perspective to include more volatile and extreme worlds like Io itself. This investigation is about more than just the search for extraterrestrial life. It's also about understanding the fundamental processes of how cosmic bodies form and evolve, and revealing the incredible surprises the universe may still hold. Io, the volcanic moon of Jupiter, has sparked captivating conversations within the realm of astrobiology, prompting us to consider if life could possibly take hold in such a seemingly hostile place. While the answer is far from simple, Io's distinct characteristics compel us to delve into this fascinating possibility. The very notion that a moon so dynamic and active might harbor living organisms is undeniably captivating. Imagine a world where, concealed beneath a surface blanketed in sulfur and ash, conditions are just right to sustain life. Although Io is famous for its relentless volcanic activity, its environment also possesses elements crucial for biology, including oxygen and various chemical compounds. You might wonder how these elements factor into our broader quest for life on other worlds. When you contemplate Io, the subject of water inevitably comes to mind, as it is the cornerstone of life as we understand it. Even though Io is an exceptionally arid moon, scientific studies suggest water could persist there as ice, either deep within its interior or scattered across its surface. Could this frozen water provide a sanctuary for microscopic life forms? Science has repeatedly shown us that life can flourish in the most extreme places, from the crushing depths of our oceans to incredibly frigid landscapes. The volcanic activity on Io presents its own set of intriguing questions. The moon's volcanoes don't just spew lava, they also vent gases that could contain vital chemical compounds. Is it conceivable that undiscovered organisms could utilize these gases for energy? The history of our own planet demonstrates that, even against overwhelming odds, life finds a way to endure and adapt. Our exploration of Io also forces us to reconsider the very definition of life. Here on Earth, we've discovered microbes thriving in incredibly harsh settings, such as the hydrothermal vents on the ocean floor. If these tiny organisms can survive in what appears to be impossible conditions, why shouldn't we entertain the idea that something similar could exist on Io? Scientists have put forward the theory that, despite Io's extreme surface, there might be entire ecosystems hidden underground. The thought that a world of ice, lava, and sulfur could conceal life within is utterly compelling. What kinds of creatures could possibly inhabit these hidden realms? You can picture organisms that harness volcanic heat to survive, forging a unique life cycle on a world that appears lifeless at first glance. Research into Io has also prompted us to explore the potential for life based on silicon instead of carbon. On Earth, all life is carbon-based, but silicon chemistry might present a workable alternative in completely different environmental conditions. Could Io be the home of a life form entirely unlike anything we know? This concept challenges us to broaden our perspective and reevaluate what we consider to be alive. Space missions have delivered priceless information about Io, reigniting our interest in studying it further. Every new piece of data brings us a little closer to answering the ultimate question: does life exist on Io? The possibility that these investigations could uncover evidence of life, even on a microscopic scale, is a thrilling prospect. You have to wonder what secrets Io is hiding beneath its constantly shifting surface. Observing Io has been a remarkable journey, allowing us to slowly piece together the puzzles of this volcanic moon. Did you know that despite being over 600 million kilometers away, Io has become one of the most intensely studied objects in our solar system? Telescopes have been essential to this endeavor, transforming what was once a mere speck in the sky into a world brimming with activity and wonder. Since its discovery by Galileo Galilei in 1610, Io has captured the imaginations of astronomers. But how is it possible for us to see something so incredibly distant? Imagine a telescope as a colossal magnifying glass designed to gather light. The more light it can collect, the finer the details it can resolve. Modern telescopes are engineered to detect light across a wide spectrum, enabling us to see not just invisible light, but also in infrared and ultraviolet wavelengths. Each new piece of information represents a small advancement in comprehending our own past and the history of our solar system. The fascination with water on Io is mirrored in popular culture, where films, novels, and television shows have often explored the concept of life on extraterrestrial moons. Yet, the science underpinning these ideas is every bit as compelling, with the search for water becoming a common thread that links scientific inquiry with human imagination. Ultimately, we must recognize that the hunt for water on Io is a stark reminder of just how little we truly understand about our own cosmic neighborhood. Every discovery and each new mission raises a host of fresh questions. The exploration of Io and its potential water sources is therefore not just a voyage into the unknown, but also a journey into ourselves and our own profound curiosity about the universe. So, as we continue to gaze at the stars and investigate Jupiter's moons, let's remember that every small discovery inches us closer to understanding the very essence of life. Who can say what other secrets the immense cosmos has in store for us? The search goes on. Imagine you possess multiple sets of lenses, each one allowing you to perceive the world in ways you never thought possible. Our comprehension of Io has evolved in tandem with the development of telescopes. Did you realize that many of the features we've identified on its surface, including craters and active volcanoes, were discovered through meticulous observations right here from Earth? Picture an artist who, rather than using a canvas, paints a masterpiece directly onto the sky. This is essentially what astronomers achieve by using incoming light data to reconstruct Io's appearance and surface activity. A pivotal moment in the observation of Io arrived with the development of high-resolution telescopes. These powerful instruments enabled us to witness changes on Io's surface that directly point to its volcanic nature. Have you ever considered how a volcano can make a moon so incredibly distant appear so vibrant and alive? This activity was vividly documented in images that captured eruptions and flowing lava, offering us what felt like a front-row seat to a spectacular natural event on a far-off world. Astronomers have also employed the occultation method, which involves monitoring Io as it passes in front of a distant star. By analyzing how the star's light fades and subsequently returns to its full brightness, they can deduce crucial information about Io's thin atmosphere and its chemical makeup. It's akin to viewing a brief film where the protagonist, Io, glides across the celestial stage, revealing secrets about itself simply by obscuring the light behind it. This technique proved fundamental in comprehending the delicate atmosphere that envelops this moon. Of course, these observations aren't confined to ground-based instruments. Space telescopes, most notably the Hubble Space Telescope, have delivered breathtaking images of Io, empowering scientists to examine its surface with a level of clarity unattainable from Earth. Can you picture watching a film in high definition after only ever seeing it in a blurry, low-resolution format? This is precisely the kind of revolution Hubble's data brought to our understanding of this volcanic world. Telescopic technology has also been enhanced through interferometry, a technique that merges signals from several telescopes to create sharper, more detailed images. You can think of it as a group of friends all taking a photograph at once, with each person's perspective contributing to a richer, more complete final picture. This method has allowed us to discern details that were formerly undetectable, such as subtle variations in the temperature across Io's surface. But what do we learn when we view Io through telescopes that operate at different wavelengths? Data gathered in the X-ray and ultraviolet spectra have unveiled new information about its volcanic processes and its complex relationship with Jupiter's magnetosphere. It is almost like possessing a superpower that lets you see phenomena hidden from normal sight. This capacity to perceive beyond the visible has profoundly deepened our grasp of how Io interacts with its cosmic environment. These technological leaps in telescopic observation have also brought about unforeseen discoveries. By studying how Io interacts with the other celestial objects within Jupiter's system, astronomers have been able to make further deductions about its internal composition and activity. Imagine each new observation as a single piece of an enormous cosmic jigsaw puzzle. While one piece might seem insignificant alone, together they create a far grander and more coherent image. The synthesis of telescopic imagery with data from dedicated space missions has enabled scientists to construct a much more thorough profile of Io. Through this collaborative approach to research, we have learned that this moon is not merely a volcanic hotspot, but a remarkable natural laboratory that instructs us on the geology and dynamics of celestial bodies. Who could have imagined that such a remote world would have so much to teach us? Telescopic observations have been, and will undoubtedly remain, a cornerstone of our exploration of Io. While we have dispatched spacecraft for close-up studies of this moon, observations from Earth provide a crucial complement that enriches those missions. Every new telescope constructed, and every innovative technique devised, brings us another step closer to solving the many mysteries that Io still holds. So the next time you gaze up at the night sky and spot a brilliant point of light, take a moment to consider that it might be Io, the volcanic moon that has captivated scientists for centuries, even from such a great distance. Its story is still being written, right here on Earth, as our telescopes continue to reveal more about its nature and its place in the solar system. This moon serves as a powerful reminder that, despite the immense distances, curiosity and knowledge can bridge even the most profound emptiness of space. What has Io's true impact been on the field of planetary science? To address this, it is crucial to recognize that Io is not simply one more moon in our sprawling solar system. Its spectacular volcanism and dynamic geology have thrown open new doors for understanding not just moons, but also planets and their formation. Every single discovery related to Io has forced us to reconsider what we believed we knew about the mechanics of celestial objects. The allure of Io can be compared to the excitement a child feels when unwrapping an unexpected present. Each time we investigate it more deeply, we are met with new questions and fresh wonders. How can a body so small generate such an immense amount of heat and activity? This very question has prompted scientists to overhaul their theories regarding the formation of celestial bodies and the complex dynamics of their gravitational interactions. One of the most profound areas of influence for Io is our conception of geological processes. Before we studied it, the prevailing belief was that significant tectonic and volcanic activity was a trait exclusive to certain planets. However, the revelation of active volcanoes on Io proved that moons too can be extraordinarily dynamic worlds. This discovery has encouraged us to search for signs of activity on other celestial bodies that might otherwise appear geologically dormant. Comparing Io to other bodies in the solar system has also been an incredibly enriching aspect of planetary science. By examining the differences and parallels between Io and its neighbors, such as Europa and Ganymede, researchers can formulate conclusions about the geological history and divergent evolution of these worlds. It is much like studying three siblings who, despite sharing common family traits, each possess a completely unique life story. Io's influence even extends to how we perceive the potential for life on other worlds. The moon Io's intense conditions and dynamic geology force you to reconsider the very definition of a habitable world. This challenges us to entertain the possibility that life could thrive in environments previously thought to be completely inhospitable, thereby broadening the entire field of astrobiology. Io has left an indelible mark on planetary science, fundamentally altering our views on geological activity, the interplay of celestial bodies, and the prospects for life beyond our own planet. Every new piece of information we gather about Io seems to generate more questions than answers, compelling us to push our exploration further and deepen our comprehension of the cosmos. The legacy of this moon in planetary science stands as a powerful symbol of the boundless curiosity and ingenuity that drive humanity's journey into space. Its relationship with Jupiter is a particularly compelling part of its narrative, as the gas giant's immense gravitational pull not only shapes Io, but also serves as a case study for how these forces can dictate a world's geology. This gravitational dance between Io and Jupiter is a vivid reminder that the cosmos is a web of interconnected forces and objects. The data returned from missions to this moon have also been a major catalyst for technological advancement in astronomy. The specialized tools created to study Io, from advanced imaging systems to atmospheric analyzers, have unlocked discoveries in numerous other scientific areas. This progress is cumulative, like constructing a ladder that allows researchers to reach ever greater heights in their pursuit of knowledge. You might be surprised to learn that investigating Io has directly influenced the search for life throughout the solar system. By understanding its volcanic processes and tenuous atmosphere, scientists have been forced to contemplate the kinds of extreme conditions that might still permit life to exist. This has significantly expanded our search parameters, leading us to investigate locations once dismissed as barren, but which might now be seen as potential sanctuaries for life. The moon's effect on planetary science is also clear in the evolution of how we observe our own world. The capabilities of our telescopes to gather light from distant objects have advanced considerably, with much of that progress tied to the necessity of observing the unique phenomena occurring on Io. Every improvement in observational technology not only brings us a clearer picture of Io, but also unlocks new potential for exploring the wider universe. Another critical contribution is Io's value in modeling the creation of planetary systems. Through the study of its composition and orbital dynamics, scientists can extrapolate that knowledge to systems around other stars. This helps refine theories on how planets and their moons take shape across the galaxy, demonstrating how a single small world can possess truly cosmic importance. As our scientific capabilities grow, so does our fascination with Io. Information gathered by missions like Galileo and Juno continues to spark fresh inquiries into the moon's origins and evolution. Each discovery is like finding a new piece of a grand puzzle, helping to complete a more detailed picture of our solar system's history. Io's influence also permeates public education and scientific outreach, igniting an invaluable sense of wonder in people of all ages and encouraging a deeper engagement with the great questions of the cosmos. In this way, Io is more than a mere object of study. It has become a genuine source of inspiration. The ongoing research has shown that science is never static, but is instead a constantly evolving journey of exploration. Io has not only altered our understanding of the universe, but has also spurred the creation of new theories and technologies that will empower future generations of scientists. Looking ahead, it's certain that the exploration of Io will remain a cornerstone of planetary science, with upcoming missions promising to illuminate even more of its enduring mysteries. Human curiosity has always compelled us to venture toward the frontiers of space, and one of the most captivating destinations in our solar system remains Io, Jupiter's hyperactive moon. As our technology improves and our knowledge deepens, new plans for future missions are taking shape. One of the most compelling questions is what revelations these next explorations might bring. For instance, the Europa Clipper mission, slated for launch in 2024, could yield significant insights, even though its primary target is another of Jupiter's moons. While Europa Clipper focuses on its namesake's subsurface ocean, it would be remarkable if its advanced instruments also captured valuable data on Io's volcanic activity. The dynamic interplay between these Jovian moons could unlock entirely new avenues for space exploration. Similarly, the Jupiter Icy Moons Explorer, also known as the JUICE mission, is scheduled to launch in 2025. While it will study several of Jupiter's icy satellites, it has specific objectives for Io, including creating detailed surface maps and investigating its geology to better understand its intense volcanism.
Beyond these confirmed missions, even more ambitious projects are under consideration. One such proposal is for an orbital spacecraft designed exclusively for studying Io. The purpose of such a dedicated orbiter would be to provide continuous, detailed observations that are simply impossible with brief flybys. An orbiter would allow us to monitor changes in Io's volcanic eruptions and atmospheric composition in real time, offering an unprecedented view of this dynamic world. Such information could reveal secrets about this moon's formation and its evolution over many millions of years. However, orbiters are not our sole option, as landing missions feature prominently on the wish lists of numerous scientists. What if it were possible to send a probe to touch down on Io's surface? This would represent an incredible challenge, considering the harsh environment and Jupiter's intense radiation. Still, a successful mission of this kind could gather samples and conduct direct analysis of the moon's soil composition, letting you imagine what it would be like to hold a piece of Io right in your hands.
The potential for discovery does not stop there. Future explorations might incorporate advanced technologies, like drones or rovers, capable of navigating across its surface. Can you envision a compact robot venturing through Io's volcanic terrain, transmitting back high-resolution images and data from its surroundings? Undertaking a field mission in such a distant location would completely transform our knowledge of how these active geological systems operate. Nevertheless, missions like these are fraught with considerable obstacles. The powerful radiation field surrounding Jupiter could easily fry sensitive instruments and compromise the entire endeavor. How can we possibly safeguard our equipment? This makes research into radiation-hardened materials and advanced shielding technologies absolutely essential. Furthermore, the immense distance separating Io from Earth poses significant communication challenges, as every message transmitted and received would be subject to delays of several minutes. Funding also represents a major consideration. Space missions demand huge financial commitments, and in a world facing many urgent issues, the competition for these resources is intense. So, how can we make certain that Io continues to be a top priority target for exploration? The solution might be to convincingly demonstrate the scientific value of studying this moon, not only for its volcanism, but for what it can reveal about the formation of celestial worlds and the prospects for life in extreme conditions. As the scientific community fosters greater collaboration, international partnerships are beginning to form. What part will other nations play in these upcoming expeditions? Global cooperation could introduce a wider range of ideas and resources, which might speed up the creation of innovative missions that bring us closer to solving Io's enduring mysteries. Ultimately, the future of missions to Io appears promising and rich with potential. Every new expedition offers a chance not just to expose the secrets of this captivating moon, but also to broaden our understanding of the solar system and the cosmos itself. As we press forward with these explorations, the question on everyone's mind is a simple one. What astonishing discoveries are waiting for us, and how will they reshape our perception of life in the universe? Io, arguably one of the most compelling moons in our solar system, has long sparked the creativity of both scientists and artists. Since its discovery, Io has been woven into myths and legends, with its name tracing back to Greek mythology, where Io was a priestess of Hera who was turned into a cow. You might wonder what connection a volcanic moon could possibly have with an ancient Greek goddess. The explanation is found in its remarkable character.
Io is more than just a body in space. It is a world that conjures the great mysteries of the cosmos and the possibility of life existing beyond our own planet. When you picture Io, it's difficult not to conjure a scene of incredible drama. A world of fire and lava, with its perpetually active volcanoes creating a landscape in constant transformation. Have you ever considered how a place so hostile, yet so captivating, could even exist? Io's volcanic activity doesn't just make it a geological marvel. It also positions it at the very heart of discussions about astrobiology. The very notion that such an extreme environment might sustain some form of life fundamentally challenges our definitions of habitability. Within popular culture, Io has made appearances in a wide array of artistic and fictional works. Its depiction varies from science fiction movies to novels, yet it is consistently linked with the unknown and the enigmatic. This makes me question why Io strikes such a profound chord within our culture. The reason might be found in its sheer uniqueness. Humanity's deep-seated fascination with the bizarre and the alien is a persistent theme, and Io, with its rugged, fiery surface and relentless volcanic activity, perfectly captures this allure. The myths associated with Io extend beyond just its name. Certain modern theories propose that Io's volcanoes might have been the inspiration for ancient tales of gods and heroes. In the same way Greek deities were described as throwing lightning bolts or conjuring storms, Io's volcanic plumes seem to wield an almost godlike power. The idea that this moon's spectacular eruptions could have shaped the beliefs of ancient civilizations serves as a reminder of the frequent overlap between science and mythology. In modern literature, Io has often been employed as a powerful symbol of human exploration and our unending quest for knowledge. Authors have integrated its story into narratives centered on survival and discovery. The concept of dispatching missions to Io to investigate its geology and potential to support life mirrors our own collective desire to venture into the unknown. As a species, aren't we perpetually searching for new frontiers to explore and understand? When discussing Io, it becomes impossible to ignore how science fiction has granted it a kind of immortality. Countless books and films have imagined human colonies on far-flung worlds, and in many of these narratives, Io is a central feature. Visuals of its blazing surface and thin, toxic atmosphere have captivated the minds of generations. It is possible that one day we will view Io not merely as a subject of scientific inquiry, but as a future destination for humanity. Io's influence on the arts is equally significant. Painters and sculptors have tried to convey its essence through various mediums, portraying its volcanic vistas and vivid coloration. These creations reflect not just Io's raw beauty, but also humanity's innate longing to form a connection with what exists beyond our homeworld. In this way, Io serves as a conduit between the realms of science and art, blurring the traditional lines that separate these two disciplines and inspiring a richer understanding of our universe. This brings us to an interesting thought. Could music serve as a medium for exploring the cosmos, a way to honor the universe's magnificence? Beyond the realms of science and mythology, Io has also captivated philosophers, prompting profound questions about our own existence. The sheer fact that such a hostile world is so geologically dynamic can be seen as a powerful metaphor for the tenacity of life itself, echoing our own persistent drive to comprehend the universe and our role within it. Each new piece of information we gather about Io only opens up a fresh set of inquiries. The investigation into its potential for life, its unique geology, and its atmospheric composition is merely the beginning of a much larger journey. Researchers are now starting to perceive Io not simply as an object for study, but as a frontier where the very definition of life could be broadened. As our capacity for space exploration grows, Io's profile in popular culture expands, which both underscores its scientific value and cements its status as an icon for the future of discovery. This all leads to a crucial question. Might Io hold the secrets to understanding other worlds and their capacity for life? When you consider Io's influence on our culture, it becomes evident that this moon has made a lasting impression on our collective consciousness. Its narrative extends far beyond scientific data, weaving through mythology, art, and philosophy. And as we venture further into the cosmos, Io will continue to be a symbol of curiosity, a constant reminder that the universe is teeming with secrets waiting to be discovered. Investigating Jupiter's captivating moon, Io, involves a set of significant challenges that scientists are keen to overcome. But these hurdles also present unique opportunities. One of the most immediate difficulties is the immense distance involved. If you think about it like a road trip, it's one that would span several years, meaning that data transmission is incredibly slow. This delay demands that every action taken to explore the moon must be planned with extraordinary care, ensuring each image and measurement is executed flawlessly. Furthermore, the intense radiation field from Jupiter poses another severe threat, acting like a destructive star that can cripple the sensitive instruments on our probes, making data collection incredibly difficult. Consequently, a primary engineering challenge is to develop spacecraft robust enough to survive this harsh environment, requiring innovative protective solutions, much like a sturdy shield deflects an attack. However, these difficulties are not without their rewards, as every challenge offers a corresponding opportunity. For instance, exploring Io provides an unparalleled chance to gain new knowledge about volcanism, a process that shapes not only other celestial bodies but our own planet as well. This effectively makes the moon a perfect natural laboratory for studying geology under extreme conditions, which could fundamentally change our grasp of geological processes. A further significant obstacle is the limited availability of resources for such ambitious missions. Space exploration carries a high price tag, and securing the necessary funding for Io-focused research can be a competitive process. Despite this, the potential returns are staggering. Imagine discovering indications of life, or even just the conditions that could sustain it. A breakthrough of that magnitude would not only reshape the search for life throughout the universe, but could fundamentally alter our perception of humanity's place within the grand cosmic scheme. Technology also plays a pivotal part in this endeavor, as each new mission drives the creation of advanced systems that often find applications far beyond space exploration. For example, data analysis techniques developed for Io could be adapted for medical diagnostics. Yet, one of the most exciting aspects is the potential for completely unforeseen discoveries, since the history of space travel is filled with moments that caught us by surprise, from finding water on Mars to the icy moons of Saturn. Io could very well be the source of the next great revelation, perhaps holding clues to the formation of our solar system, or even the origins of life itself. The sheer scale of this exploration presents a challenge that may be too great for any single nation to undertake, which in turn creates a remarkable opportunity for international collaboration. By combining their resources, knowledge, and efforts, space agencies from different countries can launch joint missions, which would represent not only a scientific triumph, but also a powerful symbol of global unity. Similarly, while interpreting the vast amounts of data can be a slow process, scientific conferences provide essential forums where researchers worldwide can share their findings and theories, fostering a dynamic exchange of ideas that deepens our collective understanding. Finally, the necessity of long-term planning presents its own set of difficulties, as missions to Io are not impulsive ventures, but require decades of meticulous preparation. Yet, with each passing day, our tools and knowledge base expand, allowing us to slowly assemble the pieces of this cosmic puzzle. Every small fragment of information we add brings us one step closer to revealing the full, astonishing picture of this distant world. Investigating Io feels like opening a captivating cosmic novel, one filled with profound mysteries and astonishing revelations. When you observe this volcanic moon of Jupiter, you are naturally led to ask what profound secrets it conceals within its fiery core. The answers to these questions challenge us to contemplate the very essence of scientific inquiry and the pursuit of knowledge. From the moment it was discovered, Io has captivated the imaginations of researchers and space enthusiasts with its sheer uniqueness. You are asked to envision a world where volcanoes are in a constant state of eruption, spewing lava and gas in a phenomenal display of geological power that is unmatched anywhere else in our solar system. In this regard, Io is not merely an object for academic study. It is a dynamic stage where the grand forces of the cosmos are actively playing out. The constant geological turmoil on Io is not a random occurrence, but is intrinsically linked to its relationship with Jupiter. The immense gravity of the gas giant creates a complex interplay between the moon's geology, volcanism, and tectonics. This raises a fundamental question about how such a relatively small celestial body can endure such overwhelming gravitational stress, prompting us to delve into the core principles that govern our universe. Io's atmosphere, while tenuous, presents another layer of intrigue with its rich composition of elements like sulfur dioxide. This prompts inquiries into how atmospheres can form and persist on such extreme worlds, which may offer clues about the conditions necessary for life elsewhere. Furthermore, the moon's internal heat, perpetually generated by Jupiter's gravitational pull, sustains its volcanic activity in a process of tidal heating, making us wonder what other moons might function in a similar fashion. Placing Io in context with its neighboring Galilean moons, Europa, Ganymede, and Callisto, helps us to better appreciate its distinct character. Each of these worlds possesses its own unique traits, much like individual characters in a grand cosmic drama. The lessons we can learn from Io's fiery nature, when contrasted with its icy siblings, remind us that space exploration is a quest to identify patterns and connections across a diverse solar system. Our unfolding understanding of Io owes a great deal to dedicated space missions, particularly the Galileo and Juno probes. The data gathered through these incredible efforts has completely reshaped our perspective on this volcanic moon. The success of these past endeavors fills us with a sense of hopeful anticipation for the groundbreaking discoveries that future missions are destined to reveal. Io's influence on the field of planetary science is undeniable, as it has taught us invaluable lessons about the complexity of celestial bodies and their intricate interactions on a cosmic scale. This knowledge, in turn, deepens our comprehension of Earth and its own unique position in the universe. Our quest to understand Io also resonates with our innate curiosity, finding a place in popular culture, from science fiction stories to ancient mythology, reflecting our deep-seated need to explore beyond our terrestrial home. The future of studying Io is filled with immense possibilities and significant challenges, but our capacity for exploration is continually advancing with new technology. Each new instrument and mission represents another significant leap forward in our quest to unlock the universe's secrets. It is crucial, however, that we also focus on education and science outreach, ensuring that younger generations are inspired by these cosmic pursuits and are encouraged to embark on careers in science. Ultimately, every challenge and opportunity involved in studying Io is part of a much larger journey of discovery. Each step we take to comprehend this volcanic moon is not just a movement toward exploring the cosmos, but also a step toward understanding ourselves and our place within it. Every small finding brings us closer to answering fundamental questions about life and the future of humanity, making the exploration of Io an exhilarating and essential endeavor.